BMM3521. We are from group 4. We represent for experiment 1, Bernoulli principle. In Bernoulli principle, it states when the fluid flow at certain velocity, the pressure surround it will decrease. For example, when the velocity of fluid flow increase, the pressure surround it will decrease. We can see Bernoulli equation, which represent the relationship between the strain, velocity, and elevation. In this experiment, water with constant velocity will flow through a horizontal path with different cross-section area. The pressure head, 1, 2, and so on, are recorded using virtual instrument installed at cross-section. The exact velocity, friction, and head can be determined by calculating the actual discharge. That's all from me.
My name is Muhammad Shahiram bin Zakaria, matric number MA17014. I would like to continue with the objective of the Bernoulli theorem experiment. The first objective is to design a complete measurement technique and assess the output for the fluid flow. Second one is to analyze experimental and theoretical Bernoulli theorem result. And lastly, to test the Bernoulli theorem for viscous and incompressible fluid in experimental setting. For the scope of the experiment is to determine the total pressure head, static head, and the dynamic head. Next, we go to the theory and background of the Bernoulli theorem. The basic principle of Bernoulli theorem involving the pressure and the velocity of the fluid. The higher the velocity of the fluid, the lower the pressure inside the tube. When the fluid is flowing through a very cross-sectional region of the tube, when the cross-section is small, the velocity of the fluid increases and the pressure at that point decreases. The potential energy, kinetic energy, and pressure energy are the most significant from the perspective of the subject. Next, we go to the test setup for the Bernoulli experiment. The setup that are needed are pitted tube, multi-tube manometer, venturi tube, motor pump, water tank, water flow control valve, manometer valve, single pitot manometer valve, pipe valve, and lastly stopwatch. Next, we go to the method and the procedure of the experiment. The first step is the pipe valve, manometer valve, and water flow control valve are all checked to make sure they are working properly. Second one is the raising the speed of water flowing by regulating the water flow valve. The motor pump was started, so the water was overflowing in the manometer valve and single pitot manometer valve in order to remove any air bubble from both manometer. Next, the single pitot manometer valve and the manometer valve were both shut closed. Next is the pump was stopped. After that, pump valve 2 was closed and pipe valve 1 was remained open. The sixth step is the manometer valve and single pitot manometer valve were deliberately opened to allow airflow into the system. Next step is the manometer and single pitot manometer valve were closed when cross half of the column. Next, the manometer valve and the single pitot manometer were opened. The ninth step is the pipe valve 2 was fully open. The next step, the starting from the tube 1 to tube C, the water flow control valve was set so that the placement of all the water level in the manometer could be read. The 11th step is the pitot head and static head measurement in the venturi tube were read and recorded. Lastly, the flow rate was calculated using stopwatch to monitor the raising of the water tank. The first precaution for the experiment is the parallax error. In order to remove parallax error, make sure the eyes are in the right direction when taking a reading at the indicator. The second precaution is to ensure there is no air bubble in the manometer and the venturi tube. The last precaution that are taken, the mean reading must be closely monitored since the reading are constantly fluctuating or unstable.
Hi, my name is Lokman Hakim, MA17053. So I will proceed with the result. Given volume is 5 liters, time taken is 22 seconds, and the flow rate Q is equal to 0.0002273 meter cube per second. And then from the data given, we can find Q, H dynamic, V measure, and also V calculation, and also the pressure dynamic. Okay, so given 6 point, so for the point 1, H stat is 180, H by third is 185, so H dynamic is the differences between H by third and H stat. So 185 minus 180, we get 5 millimeter. And then we can calculate the V measure, which is the square root of 2G times H dynamic over 1000. 2G, G is the gravitational force, 2 times 9.81, H dynamic is 5 over 1000, which is equal to 0.3132 meter per second. And then we can calculate the V calculation. V calculation is Q over cross-sectional area of duct. So for the cross-sectional area of duct is pi d squared over 4. As we have 6 points, each point have different cross-sectional area of duct. So for this point, cross-sectional area of duct is 0.0006335 meter squared. And then after that we can calculate, after we get the V calculation, and then we can calculate the P dynamic, which is equal to rho GH dynamic. So rho is 1000 times 9.81 G, and H dynamic is 5. And then we can get the P dynamic.
So the aim of the experiment was to design complete measurement technique for fluid flow and verify the Bernoulli theorem experimentally. Based on the test result, we can conclude that the experiment was successful because there is difference in measured and calculated velocity. This is because of the friction loss in real fluid, as the ideal fluid does not have friction loss. We also can conclude that the fluid flows horizontally, so that no change in gravitational potential energy occurs, and increase in fluid velocity is associated with a decrease in fluid pressure.